Hi friends, this video about Lagrange multiplier method. The multiplier method is a more powerful method when we are going to find the extreme values of a given function with some constraint. Okay, so I want to find the extremum of f of x comma y comma z subject to the constraint g of x comma y comma z equal to some k. This is the constraint. So this is f of x comma y known as the my adjective function. This guy is known as the constraint. What we are going to see how to find whenever non-constraint function we can easily find using the double derivative test or single derivative test. But in our case, some constraint is placed there, so I want to deal it. So how we can solve what is the Lagrange multiple method says? That is only the motive of this lecture. First step, we want to find the level curves. What is the level? So we set the level curves. Level curves. What is the level curves? Nothing but your f of x comma y comma z equal to some c. You take it. So to understanding purpose, I will take it the only two variables. So that is good for to understand the concept. I can draw the graph also. So f of x comma y comma c and their constant. This is called level curves. Level is nothing but so you want to take the all the levels. So different of c, you will get different of level curves. That's why it's called level curve. The plural is you can vary the c constant c. For example, now I will take it as your function f of x comma y is x square plus y square. This is your objective function. So I will take it as 1. I will get the circle with radius 1. If I take the x square plus c equal to 4, I will take the radius is 2. Similarly, I will take it. Now, next step, when my constraint g of x comma y is intersect that point. Suppose I will draw the graph. Suppose I will take the my constraints are first I will take the level curves. These are my first level curves c equal to 1 and c equal to 2 and c equal to 3. Okay, then my constraints are like that. So what are the my extreme values must be? So those points only we want to evaluate. These are the points. So these points are called intersecting with the constraint. So I will denote it as those points are xi, comma ya. Here I equal to 1 to some n. So these level curves sometimes didn't touch your. So this constraint sometimes didn't touch the all the level curves. Some level curves only will touch. Okay, suppose in this example, this level curve c equal to 1, this level curves didn't intersect the constraint. So it's really very clear. This need not be touched to the level curves. So I want to find all the value and a1. It happens. Why it is happening? It happens. The level curves and constraint. The level curves and the constraint have the common tangent line or same tangent line. So what it suggests? It suggests these normal lines are identical where their point are touching. Suppose I will take the point, touching points are xi comma yi. In the point, the normal line at x comma y comma n, the normal line are identical. This implies, so what it suggests? It suggests your gradient vectors are parallel. So this is our key point. Why? Because every time I cannot draw the level curves, I will when it's intersect, it's very complicated to solve. Okay, but we know that the gradient vectors of constraint and the given extreme functions, all our objective functions are always parallel. This is the key point. So I can write it as gradient of f is equal to gradient of g with some constant lambda. So this lambda is a some constant because I know that the gradient of f and gradient of g all are parallel. So this implies gradient of f equal to some constant times gradient of g. Okay, this this lambda is known as the Lagrange multiplier constant. Lagrange multiplier constant or Lagrange constant. Constant. So whenever the given problem, you no need to find the level curves, but simply the gradient vectors are parallel. This is the very beautiful way we can conclude. So how we can find the extremum values of the given function. So next video we can see one example how to solve the Lagrange multiplier method. Thank you.